Good morning. Here we have notes for Chapter 1, Section 5. Now we skipped over Section 4 just because we were in equations in Section 3, and Section 4 is inequality. So we're going to stay with the equations, and then we'll come back to Chapter 1, Section 4. The warm-up here is to solve for x. Notice I have some things in the denominator. And my common denominator here is 5. So I'm going to want to get rid of those 5s by multiplying everything by 5. We do have an extensive section on these types of equations, but for right now, we're going to do it this way. 5 times 3 is 15. This would be 15ax. Divided by, and of course this is 5 over 1, and I do 1 times 5 is 5. Okay, 5 over 1 times 4 is 20. It's negative. Don't forget about c. And then of course 5 times ax equals 5ax over 5. Now I'm going to simplify it. 5 divides 15 3 times, so I've got 3ax, subtract 20. C equals 5 divides 5 one time, so I'm left with ax. Now, my directions were to solve for x. Notice I have x in 2 places. So I have to get them on the same side. This would be a 3ax subtract a 2ax. Excuse me. So I'm going to take this over here by subtraction, and when I do that I get 2ax because they are like terms. And then of course I need to move this 20c over to the other side because it doesn't have an x. So this is equal to positive 20 times c. Now I'm going to divide by 2a. So x equals 20c divided by 2a, which can be simplified because 20 and 2 are even. So x here equals 2 goes into 20 10 times, it stays up top, and then the a, of course, has to stay in the bottom. So I've got this goofy looking fraction, 10c divided by a. This one over here, again, my common denominator is x minus a. So I'm going to take both sides of the equation and multiply by x minus a, and of course that's x minus a over 1. And you should see what happens, like if I multiply by something in the numerator and that same something is in the denominator, those are going to divide out, just like these 5s divided out. You see, I had a 5 here and a 5 here on the outside. They were going to divide out and leave me just with what was in the numerator. Same thing here. So this becomes, this is really quantity x minus a times quantity a minus c divided by quantity x minus a. The x minus a's are going to divide out, leaving me with an a minus c. Sorry about that. My brain is not cooperating with my hand. Okay, so again, that's a minus c equals, and now remember, this was a quantity, so you have to write it as a quantity, times m. If you don't write it as a quantity, you'll forget to distribute, and we need to distribute. On the left side, it's a minus c equals xm, or mx, and then am is subtraction, and I was told to solve for x. X is here. So what am I going to do? I'm going to take the am over here. So I get a subtract c, add am equals mx. And when I divide, I'm going to divide and switch sides at the same time. So x equals, I'm going to divide this whole quantity of 3 terms by m. So my final answer is a subtract c subtract am. I have no like terms here, so I can't put them together. And I'm dividing by m to get the x by itself. So a little practice, maybe you want to write that problem down and see if you are able to do that on your own. Today's lesson involves solving absolute value equations, and that's the title of the notes for this chapter and section. Absolute value, well, let's give it a definition. The absolute value of a number is the distance that number is from 0 on the number line. You've got to keep in mind that distance, measurable distance anyway, is non-negative. That's why the absolute value of 2 is 2, and the absolute value of negative 2 is also 2, because both of those numbers, positive and negative 2, are both 2 units away from 0. Absolute value of 2 is 2. Absolute value of negative 5. Negative 5 is 5 units away from 0 on the number line. And so its value is 5. And then, of course, the absolute value of 0 is 0 itself. 0 is neither positive nor negative. How do we solve absolute value equations? I'm thinking that you should have seen this in your Algebra 1 class. It's important to know that you must isolate the absolute value expression first. The thing in the bars has to be on one side of the equation by itself. Then we take what's inside the bars and we write it twice. Once for the positive case and once for the negative case. Because remember, I could have a positive number in the bars or I can have a negative number in the bars. So that's why I need 2 cases. You've got 2 bars, 2 cases. Positive case and a negative case. Then we're going to set one of those equal to the answer that's given. In other words, look here. Absolute value of x is 7. So I'm going to set up my 2 cases. 1 case, 2 case. I take what's inside the bars and write it twice. X, x. So I'm writing it for my 2 cases. And I'm going to set one of them equal to the answer given. 7 is given. I'm going to set the other one equal to the opposite of the given answer. What's the opposite of 7? Negative 7. And then we have to solve and simplify both equations. Now notice in the first example, these are my answers. 7 and negative 7. I'm done. There wasn't really much work to do there. This one, a little bit more work. Notice that the bars are already isolated. There's nothing in the front, there's nothing in the back. So I have to set up my 2 cases. I take what's inside the bars, x plus 1, and I write it twice, once for the positive case, once for the negative case. 9, negative case, be the opposite of 9 or negative 9. Sometimes this on the right side is a quantity, so you need to be careful. Now I'm not done here like I was in the first example. I have to actually take the 1 over to the other side. So I get x equals, when I subtract 1, 8, and x equals, when I subtract 1, negative 10. And absolute value equations you need to check. And you need to show me the check. And this is enough of a check to show me. X is, so I go 8 plus 1 equals 9. 9 equals 9, check. Okay, so you set it up, and then you show me the computation that left side and right side are equal. I don't need to see every step if these are longer problems. Okay, x here was negative 10. So I set up negative 10 plus 1 equals 9. You don't have to show me this is negative 9 absolute value. I can say negative 10 plus 1 is negative 9, but the absolute value of negative 9 is 9. Okay, so there's only 2 steps to show me in the check. Once it checks and you know it's correct, then you circle your answers. Okay, side 2. Example, absolute value of 3x plus 4 equaling 10. Absolute value of 3x plus 4 equals 10. Well, the absolute value bars are isolated. There's nothing in the front, and in front of the equal sign, there's nothing behind the bar on the same side of the equal sign. So I'm ready to set up my two cases. First case is 3x plus 4 equals, set it equal to the answer that's there. 3x plus 4, that's my second case, equals the opposite of that answer, or negative 10. And now I just solve. 3x equals, subtract 4, I get 6. Divide, I get x is 2. Over here, 3x equals, I'm going to subtract 4, so this is negative 14. So x equals negative 14 over 3. Now I'm going to check. I've got absolute value of 3. There's my x. 2 plus 4. Does that equal 10? The second check, I'll check it underneath here. 6 and 4 is 10. Absolute value of 10 is 10. That works. Second checking. Absolute value of 3. My x this time is negative 14 thirds plus 4. Now, you might think you need, I like to write these bars longer, you might think you need a calculator to do these. And remember, you check in the original. I'm not going to set it equal to negative 10. Okay, it's back up here in the original. You don't need a calculator. Look, these 3's are going to divide out, and it's going to leave me with negative 14 plus 4. Well, that's negative 10 inside the bars, and when I take the absolute value, I see 10 is 10. So these are, in fact, solutions to this absolute value equation. Okay, the next one. Notice, this is in the front of the bars, and this is in the back. You need to isolate those bars, 2x minus 3, what's inside the bars. So I have to add 6 first, and then I've got to divide by 5. So here I've got 5 times the absolute value of 2x minus 3 equals 10. Now I'm going to divide by 5. Absolute value of 2x, subtract 3, equals, divide, okay, 10 divided by 5 is 2. Now I can set up my two cases. 2x subtract 3 equals 2. Case 2, 2x subtract 3 equals negative 2. That's for my negative case. Okay, I'm going to move this up a little bit. I'm going to add 3, so 2x equals 5. Divide, x equals 5 halves. Over here, 2x equals 1, x equals 1 half. And now I need to check to see if these work. You have to check in the original. Always, always, always go back up to the original to check up here. So I've got 5 times the absolute value of 2. Everywhere I have an x, I leave a parenthesis. I'm going to put the 5 halves in there. Subtract 3. Subtract 6. Does that equal 4? I'm going to set up the next one right underneath it. 5, absolute value, 2. This time 1 half. Subtract 3. Subtract 6 equals 4. And I'm just going to arrow over here. Excuse me. Again, you might think you need a calculator, but I don't think you do. These 2's are going to divide out. See, this is the numerator, that's the denominator, it's division. It goes away. 5 subtract 3 is 2. Absolute value of 2 is 2 times 5 is 10. 10 minus 6 is 4. And so this works. Excuse me. Again, the 2's are going to divide out. This is 1 subtract 3 is negative 2. Absolute value of negative 2 is positive 2 times 5 is 10 minus 6 is 4. So again, we see that 4 equals 4. And now I can be sure that these are both solutions to the absolute value equation. One last problem to do, that's example 5. So I see that my bars are already isolated, but I have a problem. Do you see a problem with this problem? Could the absolute value of anything ever equal a negative number? Could the absolute value of anything equal a negative? And you've got to say no. So these are easy problems. Be on the lookout for those. Absolute value of something equaling a negative number, that's not possible. And so my solution is empty set or empty set. Okay, write one of these or the other. Please don't put this inside. I saw someone do that in one of their homeworks. You can't put the empty set inside the empty set because then the set is no longer empty. Okay, so it's either this or this, but not a combination of both. Okay, the homework practice problems for this section are on the bottom of your note sheet, which is right here. It starts on page 36. You're doing 1 to 9, number 34, and 36. Remember, if you have any questions, please ask them in class or post a comment on the homework discussion page. Have a great day.